The first general idea in calculus is a limit. Don't let the idea of calculus intimidate you. It's just the next logical progression in math after geometry, algebra, trigonometry. Limits is the idea that is the bridge between pre-calculus math and calculus. So we're going to introduce the concept of a limit today. So a limit is written LIM for limit as x approaches some number c of f of x. Now, what we're thinking about when we write this is what happens to f of x as x gets near c. We don't really care what happens at x equal to c, only when it gets near c. Now, if a function is continuous, and we're going to learn more what this word means, but for now, let's just think of it as a function that if you graphed it, there would be no lines, breaks, or gaps. So if a function is continuous, then the limit as x approaches c of f of x is in fact equal to f of c. The limit is the same thing as the function, if it is continuous. Most of the functions you've come across, polynomial functions, linear functions, quadratic functions, trig functions, they are all continuous. There's no strange behaviors there. So if you want to evaluate what the function is, if you want to evaluate what the limit of the function is at a particular point, the very first thing you do is you plug that point into the function. So for example, if you wanted to know what the limit as x approach 2 of x squared minus x minus 2, you look at that function, oh, that's a quadratic, you know it's continuous, so all you do is you plug the 2 in, and if you plug 2 in, you get 2 squared minus 2 minus 2, which is in fact 0. So the function is equal to 0 at that point, and so is the limit. Now, so the very first step is just plug it in. If you plug in and some strange things start happening, you get some results that aren't typical, then there's other things you need to do. For example, let's take a look at another function. Let's find the limit as x approaches 2 of the function x squared minus x minus 2 over x minus 2. Now, if you were to plug in 2 at this point, you see you get 2 in the numerator and you also get 2 in the denominator. So f of 2 is equal to 0 over 0. 0 over 0 is not called undefined, it is called indeterminate. And I will explain a little bit where those terms come from. But when you get a result of 0 over 0, there's other things you have to do. In this case, what you would do is you would factor that original rational expression. It's rational because it's a fraction. You would factor that and see what you get. And if you factor x squared minus x minus 2, that factors into x minus 2 x plus 1. And then it's over x minus 2. Now you see what we could do now is these two terms will cancel out and we're left with x minus 1. If we plug 2 into that now, what we're going to get is 3. So the limit of x approaching 2 of our original function, x squared minus x minus 2 over x minus 2, is equal to 3. 3 is not what you get when you plug 2 into that function. But when we did our additional work by factoring, canceling out the term, plugging in what we are left, we do get the equation 3. Now, if you were to graph this function, x squared minus x minus 2 over x minus 2, it may not be what you would think it would be. It would actually turn out to look like the function x plus 1. And let's go ahead and graph the function x plus 1, and I'm going to make a point on this function. If we were to graph our original function, x plus 1 has a y-intercept of 1 and a slope of 1, so it's going to look something like this. It's going to be a linear function. However, there's going to be a hole at x equal to 2. Those are our x values right there. Let's put lines on this so we know what we're talking about. Okay, and it actually does continue in either direction. So we can see from this graph of our function that the function itself is not defined at x equal 2, but the limit is. Now let's think about what this open circle means, because we've used that in math many times in the past. What that means is there's only one point removed from this line, and that one point is so tiny, so small that you actually can't see it. We draw a, shall I say, gigantic circle to represent that one point. But what it means is, as you get closer, as x gets closer and closer to 2, from either direction, it really doesn't matter, the function is going to get closer and closer to 3. The function will not equal 3 at x equal 2, but the limit as x equal 2, the limit as x approaches 2 of our original function does equal 3. Now, one last point on this example I want to make is that lots of times in the past you have written this out. You've written x squared minus x minus 2 over x minus 2, and after you factor and cancel, you say it equals x plus 1. Well, these two are not in fact equal. They are equal for every point except for at x equal 2. If I were to graph that function, it would be just like the line I just drew without that hole in it. This function looks just like that, except it has a hole at that particular point. Now, that function is not considered continuous, because we said continuous means no holes, breaks, or gaps. This one does in fact have a hole in it of 1 point. That particular type of discontinuity is called a removable discontinuity, because you can think of, if you remove that 1 point, that's how you create it. And all you gotta do is put that 1 point back and it will now be smooth. So, what is the limit? The limit is an idea of what happens to the function as it approaches that particular x value. Not what happens at that x value, but what happens when it approaches that x value. For most of the functions you're familiar with, all the continuous ones, if you want to know what the limit is at that point, you simply plug that point into the function and get your answer. We looked at a particular type of function that had a removable discontinuity. So we found out what happens at that particular point. We had to factor and cancel to find out what happens. And just to finalize our idea here, to repeat one more time, as x gets closer and closer to this 2 value, the function gets closer and closer to 3. Not what happens at x equal 2, but what happens as x approaches 2. That is our first concept of a limit, and we're going to be studying limits for probably a couple of weeks, let's say, but for just a beginning point of view, there you have it.